If you are a backcountry snowboarder, you know the age-old problem of how to get up the mountain in a more efficient way and actually keep up with the skiers that you're going on tour with. And for the better part of around 5,000 years, we had the glorious invention of snowshoes, which are basically just a large platform that you strap on the bottom of your shoe, basically increasing your surface area and reducing the amount that you sink into the powdered snow. And I'm aware that split boards have been a thing for quite some time now, and the technology has really advanced and the prices have gone down quite a bit, but I'm still currently using snowshoes, and that's something that I want to address today. A while ago I got the idea of combining the form factor of backcountry skis and snowshoes into one concept, and that is basically just create a more slimmer but longer version of the traditional snowshoes. And I also thought about making them foldable so that they can fold down into a more compact shape and fit onto your backpack without poking out on the top or the bottom, leaving you with a more enjoyable experience when you ride down the hill. Pretty quickly in my research I figured out that there is already a hybrid product on the market, and they're called approach skis, and those are just shortened but wider, smaller skis with skins on the bottom. And it's not only approach skis that exist, there are already some foldable products on the market. So I'm not claiming that I have anything revolutionary in the making here. I just want to dip my toes into the outdoor gear developing world because it's something that I'm passionate about, and I really just want to challenge myself with a complex project and try to develop a pair of foldable approach skis that are completely 3D printable. I have a deadline now that's pretty much this year, Christmas, and I want to have a fully working set of prototypes that I can take up on the mountains back home. Now, before we're heading straight into Fusion 360 and design the whole thing, I really want to get the numbers right, because with complex projects like this, you really don't want to change those critical dimensions later in the process, because it can really mess up the whole design that you're building on top of those measurements. In the end, we're gonna build a flotation device that's meant to hold us up in the snow. So surface area is the most crucial metric that we have to go off of. And with some ChatGPT and online calculator research, I found out that the average surface area of snowshoes and backcountry skis is around 3,700 square centimeters. Now, to get to the proportions of the approach skis, I roughly knew how long I wanted the approach skis to be, and that is roughly 120 centimeters. And to get to the final dimensions, I simply had to divide the average surface area by the 120 centimeters. I rounded this number up to about 16 centimeters, so the area of my approach skis will be roughly 3,840 square centimeters, which should give us some pretty good flotation and should end up with a nice and efficient walk up the hill. After about a week of on and off modeling, I'm done with the first prototype of the ski alone, because I first want to focus on that part of my project just to test out the structural integrity of the ski itself. As you can see, the ski has been separated into 6 different parts. That's just simply to fit it on top of my 3D printer. All the different segments are getting screwed together with those connectors. Those are just simple plates that go on top and the bottom of the ski elements just to permanently fixture those parts together. And the actual hinges for the ski to fold down are here in red and green. And I also modeled them as separate pieces just because I want those to be extra strong and I want to give them some extra infill and some extra walls. Once I was done with that and happy with it, I just threw all the objects into Bamboo Studio. All the plates combined will be around 1.4 kilograms of filament, and that includes all the hinges, the ski and the connectors themselves. I'm printing everything using PETG and the 0.8 millimeter nozzle on my Bamboo Lab A1 printer. And while printing the ski and everything, I used the cheapest filament I could find on AliExpress. And while I was printing that, I had a lot of problems with moisture within the filament, and I had crazy amount of stringing, so that might be a little bit of a hint on how it's going, but I just went through with it because I don't have a filament dryer at the moment. So I just printed everything out and then I just screwed everything together using M5 machine bolts. The assembly was actually quite annoying because I designed the whole ski to not use any hardware except the bolts themselves. So I just created tapered holes for the threads of the screw to actually stick in. So I actually had to use quite a lot of force to get the screws into the prints themselves, and that tended to heat up the screws quite a lot. So sometimes when I went too fast, I actually melted the filament. After about 2 days of non-stop printing and about 2 hours of assembly, the prototype is finally done and we can start with some testing. But unfortunately, the prototype is already broken into 3 different pieces. Am I pissed that I didn't record how the thing actually broke? Most definitely. And is this a little bit of a letdown and a setback? Maybe, but maybe also not. After all, that's really what prototyping is all about, so I really don't want to be sad about it for too long, and I really want to take this opportunity to learn some lessons and go forward with this project with a deeper understanding of how we should approach this project. Now, the most important things that I want to do before I continue with this project is to source some high quality, tough PETG. And I'm also gonna be investing in a filament dryer so I can have the best quality of filament while printing this next prototype. Now, when it comes to the failure points of the print, I actually can also get some lessons off of that because I designed the central section of the ski to be quite stiff and quite overkill, so there is no real flex in the middle section of the ski. And the back part and the front part actually are quite thin, and you can see there's quite some flex in those parts, which is actually a good thing because flexing actually allows the forces to be distributed along the whole length of the ski. And if one of those flexible parts ends up in a sharp corner with one of the stiff parts, that really creates a concentration of forces in that part. So those are also the most likely to snap, and that's what we see in this prototype. I think I wanna conclude this first part of this project with this failure or maybe lesson that we can take into the next part. I'm gonna upload this video as soon as possible so I can get some feedback in the comments. So if you know a good filament or a good filament dryer for me to get, please leave some recommendations down in the comments. I'm gonna do a major redesign on the ski itself while I'm also doing some research myself, and I hope to see you in the next part where we can actually do some proper stress testing of the ski without it actually snapping within the first 5 minutes of me having it done.